So everyone okay semua?
Okay.
Okay. Okay. Petang-petang ni dah mengantuk kan? Betul tak? Okay. Hampir.
Betul.
Okay. Nampak tak my PowerPoint? Okay, there's one thing so a lot of people have problem. Kalau soalan yang dia suruh lukis Lewis structure. Okay, soalan yang suruh lukis Lewis structure, apa je compound, contohnya dia bagi aluminium trifluoride. Okay, contohnya bagi macam ni kan. As we have two ways kan untuk nak buat Lewis structure dia. Ingat tak hari tu kita ada dua jenis bonding. Satu ionic dan lagi satu covalent. Okay. Kalau ionic, kalau Lewis structure untuk ionic hari tu kita ada buat itu, and kita will get the aluminium 3+ and then fluorine kan, ingat tak hari tu kita buat ionic, kita akan dapat macam ni. And for covalent we will get like this. Okay, if you guys can see this, you guys rasa yang mana satu yang betul? Macam mana you nak tahu whether aluminium trifluoride ni dia ada ionic bonding or covalent bonding?
Charge.
Yes. One thing is, kalau you remember, charge is one of the great indicators. Okay, kalau dia macam yang ada charge yang kuat tu, usually dia akan jadi ionic bonding lah. One thing yang you guys can make sure, you guys can check every single time untuk tahu dia ionic ke covalent. I don't know whether you guys nampak tak my camera ni, my periodic table yang ada electronegativity table values ni.
Nampak.
Saya ada bagi kat korang ke belum?
Ada dekat sini. Ada kat belakang penonton.
Belakang penonton. Okay. Tengok electronegativity values. Untuk tentukan ionic or covalent, you have to look at the electronegativity values. Apa ni you perlu tengok is compare the compound inside of the molecules. So, for example, aluminium is 1.61 while fluorine is usually kita akan bagi 4 lah. Okay, these values dalam buku, I think buku nota lain, buku sometimes dekat website lain. So I'm following this one website. Nanti I bagi the link kat korang. Kalau I tak bagi, tolong remind me. Usually sometimes dia orang cakap fluorine is 3.98, but most books akan cakap 4 je. So cara yang you nak tahu whether it's ionic or covalent, you tolak the electronegativity values. Okay, so you cari the difference in electronegativity values. So kalau 4 tolak 1.61 dapat berapa? Kalkulator ada tak tu?
2.
Betul tak? Dapat tak?
2.39.
Okay, 2.39. Ini bermaksud it will not form covalent, it will form ionic. Okay, kalau soalan tu suruh lukis Lewis structure, the first thing you tengok dia punya electronegativity value. Tengok difference je. If kalau electronegativity values dia is more than or equal to, it will form ionic. Okay, boleh? This one kalau you take note dekat buku korang. Kalau around 2, it will form ionic. Okay. So kalau ionic awak kena buat macam ni lah. Yang atas hari tu. So aluminium ni group berapa? 13 kan?
Yeah.
So cara nak lukis Lewis structure dia is like this. And ada 3 fluorine. And then another fluorine. Okay, cara nak lukis untuk ionic kita dah belajar itu. Cara dia macam ni, bukan macam Lewis structure untuk covalent. Kalau covalent, you tengok kurang daripada 2, senang lah. Because you buat cara step tu, kira valence electron, kira you complete the terminal atom semua tu. It's very easy. Untuk ionic, remember kan, kena buat. It shows that aluminium donate electron to the fluorine. That's why we'll get this. And don't forget the stoichiometric punya ratio. Okay, that's the one yang I nak fokus, nak terangkan balik. Because a lot of people struggle dengan that. And then 7.2, I think you can do it. And then 7.3 kita akan masuk hanya today. Okay, semua okay? Boleh?
Okay.
Okay, bagus. So hari tu kita masuk lagi kan? Sampai van der Waals forces.
Yeah.
Tak, so saya akan ulang balik intermolecular forces. Okay, one thing untuk ingat is kita mostly hanya akan cerita pasal 3 forces. Kita ada London, dipole and hydrogen bonding. So only 3 of this yang you guys kena belajar ini and akan masuk exam lah. And you also need to know the strength. Hydrogen bonding is the strongest between the intermolecular forces. And then dipole is the second one, and then London forces is the weakest one. Okay, hari tu ingat tak saya tunjuk pasal intra and intermolecular forces. Pasal my yes, my Velcro stuff ni. Okay, the thing yang kita look forward here, kita hanyalah tengok pasal intermolecular forces is forces between molecule. Okay, dia bukannya dalam molekul. Ionic covalent tu is intramolecular, which is dalam molekul. So macam the benang. So apa yang kita tengok ni is basically between molecule and molecule, they'll stick with each other. So that's why kalau you tengok you give energy to water, dia akan boil. By boiling doesn't mean the H2O akan separate. Dia takkan jadi hydrogen gas dengan oxygen gas. It's still wap air kan. Kalau you boil, you letak tangan you, even though panas, nanti you akan ada water droplets balik kan dekat tangan you.
Yeah.
Yes. That's because H2O dia tak separate. The forces yang bind hydrogen and oxygen, the covalent bonding is way stronger than the punya intermolecular forces. Okay, saya bagi tahu siap-siap. Dalam water ada hydrogen bonding. Nanti kita akan tengok hydrogen bonding. So bila you bagi heat around 100 degrees Celsius kan, boiling point dia kan. So apa yang akan break dulu is the intermolecular forces. The hydrogen bonding akan break dulu. Covalent bonding tu is very strong. We have to really hit it. Okay, remember tak dulu sekolah menengah dulu you guys ada this one experiment where you actually separate hydrogen and oxygen from water. Ingat tak macam mana korang buat? Yes, very good. So by supplying electrons, that's how we can break the covalent bonding lah. Just supplying api, we wouldn't actually change anything. Sebab kita hanyalah breaking the intermolecular forces. Okay, so I'll go back to my slide. Okay. So kita akan tengok 3 je. So ingat the thing yang you guys perlu ingat is hydrogen bonding is the strongest one. Hydrogen bonding, and then dipole-dipole and London forces. Okay, so let's see the first one. Kita tengok on van der Waals forces dulu. Kita ada dua type of van der Waals forces. Okay, satu dipole-dipole, satu lagi London forces. So dipole-dipole ni untuk polar molecule. Okay, kalau boleh tulis kat buku nota korang. And the London forces is for non-polar molecule. Okay, the reason why people found that London forces is, okay, diorang tahulah kalau yang molekul yang polar, diorang stick with each other sebab positive attract negative charge kan, negative charge attract positive charge. So diorang wonder lah, kenapa kalau London forces, contohnya CH methane, okay, methane ni polar ke tak? Polar ke tak methane ni?
Non-polar.
Yes, it is non-polar sebab the electronegativity difference is very small. It's less than, I think it's 0.3 kot, 0.35. So it's less than 4. So it wouldn't be polar. The bond pun dah tak polar. Plus it is a basic shape. So kalau dia polar pun it will cancel each other. So diorang tengoklah, kalau dia tak polar, kenapa kalau kita sejukkan methane, kita akan dapat liquid form? Macam mana those gases boleh attract and melekat to each other, lekat-lekat tu dekat-dekat ni, walaupun diorang tak polar, walaupun diorang tak ada charge untuk tarik each other. So apparently nanti kita akan tengok how non-polar molecule attract with each other. So the important thing is dipole-dipole forces is for polar molecule, London is for non-polar molecule only. Because dipole-dipole ni untuk molekul yang ada dipole moment, yang ada net dipole moment. Okay, boleh? Okay tak?
Boleh.
Lemaunya korang. Mentang-mentang pukul 1-2 ni, waktu tidur ni.
Boleh.
Oh, bagus. Okay, kita tengok dipole-dipole forces. Macam saya cakap tadi, is from permanently, is from polar molecule, and kita define it from permanently positive and negative. Okay, apa maksud dengan permanently positive and negative? This is from, kalau bond to polar, okay, kalau bond to polar, hydrogen akan most obviously ada partial positive charge, and chlorine akan most all the time akan ada partial negative charge. Sebab kalau you tengok the electronegativity table, chlorine is berapa Chlorine is 3.16 and hydrogen is 2.2. Okay. From here pun you dah tengok chlorine is way more electronegative. Lagi tamak, lagilah banyak dia nak tarik elektron. So most of the time, almost all of the time, chlorine, the electron yang dia orang share ni akan berada di chlorine. So dia akan inhibit partially negative, and hydrogen akan inhibit partially positive charge. Okay, remember why this is important, partially positive and negative, because dia orang bukannya fully positive or negative. This charge only for ionic bonding. For ionic bonding. Okay. So, dipole-dipole forces. Apa yang tertarik? So, kalau you tengok, bila chlorine negatif, okay, sebab dia ada banyak elektron, kalau you rasa negatif tertarik dengan positif tak? Would it be the, yes, dia akan tertarik dengan the positive charge of hydrochloric acid yang lain. So hydrogen yang partially positif yang lain, for molekul lain akan tertarik to the negative charge of the one chlorine. So that's what arrive of dipole-dipole forces. Okay, so dipole-dipole forces ni is basically from the negative or positive charge dia akan tarik from other molecule. Okay, the important thing is dia bukannya tertarik dengan molekul dengan atom yang dalam molekul yang sama. Dia akan tertarik dengan other molecule. Sebab kalau dia tertarik dengan molekul yang sama, is no longer intermolecular forces, is already intra dalam molekul. Macam saya tunjuk tadi, velcro dengan benang. So now kita tengok, itu saya dah terang. So kalau lah dia tarik lagi kuat, the more polar molecule, so HF is one of the between HCl. Okay, hydrogen is 2.2 while fluorine is 4 and chlorine is 3.16. So the more polar molecule, higher electronegativity difference, a stronger dipole-dipole forces. So between HF dengan HCl, korang rasa lagi yang mana lagi tinggi dipole-dipole forces? Yang mana? Apa? Yang mana dipole-dipole forces dia lagi kuat? Yes. Yup, HF. Sebab kalau you tengok, the difference between ini dengan ini is way bigger than chlorine and hydrogen. Kan? Kalau you tolak 3.16 tolak 2.2, between and 4 tolak 2.2. Okay. Obviously this one akan have more will be the more polar molecule, thus having a stronger dipole-dipole forces. Thus bila ada stronger dipole-dipole forces tu, maksudnya dia akan attract with another HF stronger. HF akan attract stronger, so dia akan attract stronger with each other. That's why it takes more energy untuk kita boil dia. Lagi banyak api ni kita kena letak untuk boilkan HF berbanding HCl. So stronger dipole-dipole forces, higher boiling point. So kalau you place more the more polar molecule will have stronger dipole-dipole forces and thus having higher boiling point. Dipole-dipole kita hanyalah kita tengok from polarity. Boleh? Okay. So now kita tengok example between propane and acetaldehyde. Okay, kalau propane you kira dia punya molar mass semua carbon 12 kan, then hydrogen 1 and then oxygen 16. You kira tambah semua, you get both sama molar mass. Kalau dalam topik intermolecular forces, kenapa kita compare molar mass? Okay, molar mass kita compare, kita kan boleh relate with the size. So kalau molar mass dia sama, kita boleh cakap that size dia is relatively also sama. Okay, tapi kalau kita tengok CH, itu kan kita cakap is non-polar kan, and then sini ada CO. The formula for this is H, and then H, and then C double bond 4 for H, while this one is CH3, CH2, CH3. Okay, kalau you tengok, this one ada oxygen. Oxygen and carbon is a polar bond. So dia ada net dipole moment. That's why dipole moment dia is 2.7 dBs. Compared to propane hanyalah 0.1. So you tengok, from this we can deduce that acetaldehyde is more polar. So kita boleh cakap polarity of acetaldehyde is bigger than propane, and thus acetaldehyde have stronger dipole-dipole forces. So between one acetaldehyde with another acetaldehyde, they have stronger dipole-dipole forces. And sebenarnya kalau propane tak ada pun dipole-dipole forces, sebab it's non-polar and it will not have dipole-dipole forces. So that's why acetaldehyde have higher boiling point than propane. And this is Kelvin, dalam unit Kelvin, SI unit of temperature, kan?
Yeah.
So now kita tengok, tadi kita tengok dipole-dipole, and now kita akan tengok London forces. So London forces yang saya cakap tadi, the important thing is for non-polar molecule only, and it is a temporary dipole moment. Okay, kenapa kalau molekul tu is non-polar, dia orang boleh stick juga kat each other. Okay, kalau tengok bromine and bromine. Okay, bromine dia punya electronegativity value is 2.96, and since dia bersantun juga dengan bromine juga, so bromine always have the same electronegativity value. So the difference in electronegativity would be 0, kan? Since dua orang have the same strength nak tarik elektron tu. Diorang tarik elektron tu sama kuat. Tarik sini, sama kuat. So what happen? This will not be a polar. Dia tak ada net dipole moment, kan? So it will not be a polar molecule. Okay, but now kenapa kita boleh nampak dia in a liquid form kalau kita beku, kan? So what happened is, kalau you ingat, the definition of orbital is the 3D space around the nucleus where the probability of finding an electron is the highest, kan? The word probability. Okay, probability cakap, so kita tak tahu, kan, sebenarnya elektron tu duduk mana. Okay, at one point elektron tu maybe kebanyakan just from this one bromine, maybe dia duduk dekat sini, maybe dia orang duduk sama banyak, but dia juga have the probability of electron from bromine 1 to be at bromine 2. Okay, at any point, or vice versa, bromine electron from bromine 2 ni maybe dia duduk dekat bromine 1. So we don't know, because that's the definition of probability. So at any moment it can have temporary dipole moment. Maksudnya dia orang takkan stay macam ni selama-lamanya lah. It will revert back to its normal. Sometimes maybe kat bromine yang 1 ni yang banyak electrons. So what happen bila at one moment this banyak elektron ni duduk dekat bromine 2. So the bromine 2 will have temporary dipole moment. Okay, buat sementara waktu dia jadi tamak sikit, dia ambil elektron ni, elektron from bromine 1. While bromine 1 buat sementara waktu ni dia jadi pemurah, dia bagi elektron dia dekat bromine 2. Even though dia orang tak ada ni net dipole moment, but for that moment dia akan ada temporary punya charge. So what happen is other molecule also will experience the same thing. So if you guys can see, now we have negative and positive charge. So what will happen, this temporary dipole moment will attract each other. That's hence what we call it London forces. Okay, boleh faham tak? So between London and dipole dia sentiasa positif or negatif. While London ni ikut sukalah. Sometimes maybe this one yang positif, maybe this one yang negatif. Okay, boleh? Betul. So kita tengok comparison between the strength pula. Apa yang menyebabkan setengah molekul have higher London forces than others? Okay, dipole tadi lagi polar, lagi kuat kan? London forces pula, kita tengok size. Sebab itulah kita compare molecular mass tadi yang saya cakap tu. Molecular mass, kalau kita kira molecular mass dia, kita boleh associate molecular mass dengan size dia. So, a bigger molecule or higher molecular mass have more electron to move around, easier to have temporary polarization and stronger that salah ni. Sorry and forces. Okay, has stronger London forces. So, apa dimaksudkan dengan ni? So, between this and this. Okay, bayangkan dua ni balon. Okay, satu balon kecil, satu lagi balon besar. You isi dengan air. So, mana yang lagi senang you picit sikit dia macam dia nak jadi bentuk lain. You nak kemetkan dia. It would be lagi senang kalau letak air kecil ni, kalau you letak atas meja dia duduk saja kan. Kalau letak air banyak, you letak atas meja pun dia dah start dah jadi kemet lah. Okay, so what it's saying is, kalau you ingat itu pasal chapter 6, kita belajar pasal across the group and down the group. So, kalau you ingat, down the group tu molecular size dia makin besar. Sebab dia punya Z efektif tu dalam stay the same, tapi dia punya shielding effect bertambah kan. So, what it's saying is, the bigger the molecule, lagi senang you nak gerakkan dia punya elektron yang dekat luar-luar ni. Lagi senang you nak kemetkan dia. Lagi senang you nak ubah bentuk dia. Okay. Sebab elektron yang kat luar ni dah jauh daripada nukleus and tak dipegang dengan kuat. Comparing contohnya macam fluorine. Fluorine is very small. Elektron ni semua dekat dengan ni. Comparing dengan maybe I would say cesium. CESIUM. Cesium is very big. They only have one electron valence and jarak daripada nukleus nak tarik electron valence tu is very far. So dia tarik electron valence tu very tak kuat comparing to fluorine. Fluorine is very small and kalau you tengok is very electronegative. So dia tarik elektron dia super kuat. So the bigger the molecule, ataupun sebab kan kita bukannya hafal kan semua saiz molekul tu banyak mana, besar mana. So kita tengok dia punya molecular mass, MR value ni. Yang dekat depan tu buku korang ada satu table tu. Dia ada simbol proton number dengan relative atomic mass. Kita tengok dia punya mass. So the bigger the mass, kita assume the bigger the molecule. Lagi senang kita nak move the electron, that's easier for it to have temporary polarization, aka temporary dipole moment. Temporary dipole moment. So, lagi banyak energy nak overcome the London forces, so the boiling point increase. So this is dia punya conclusion. So the bigger the molecule, the stronger London forces, that's the higher boiling point. Let's see the comparison. So, for example, kita ada dua yang affects London forces. Okay? Benda yang affect London forces. Chlorine gas and bromine gas. Mana lagi besar kalau korang tengok?
Bromine.
Yes. Bromine. Kalau saya tak lukis ni pun, you guys should know that bromine is bigger. Sebab you guys tengok you punya periodic table, chlorine and bromine is group 17 kan? Group,
Jangan turun.
yes. Down a group, dia punya size Size increase kan. Down the group, shielding effect increase. So, kalau you tengok, fluorine is the smallest, chlorine besar daripada fluorine, and then bromine besar daripada chlorine, and iodine besar daripada bromine. So, macam tadi kita cakap, bigger molecule are easier to polarize, thus having stronger London forces. So that's why bromine 2 dalam liquid version have higher boiling point than chlorine. Also, molecular size is not the only factors that affect London forces. Excuse me. So, also molecular shape. So, this is N-pentene and also 2,2-dichloromethylpropane. Okay, diorang punya molar mass is the same. Kalau you kira, they have the same amount of hydrogen, same amount of carbon. Okay, yang putih ni hydrogen, while hitam ni carbon. Okay, they have the same amount. So, molar mass dia is the same. Okay, so macam tadi kita cakap, molar mass kita boleh relate dengan size. So, kita will assume that N-pentene and 2,2-dimethylpropane will have the same size. Diorang ni macam size yang sama. Tapi, as we get from the experimental data, we get it that 2,2-dimethylpropane it has higher boiling point. Alamak, kenapa dia have higher boiling point? Sebab, kalau you tengok, N-pentene ni, kalau molekul geometri dia, you boleh guna Argus Lab untuk buat yang software tu. Geometri dia bentuk bulat, while this dia macam bentuk membujur. Okay. So, apparently, this also affect London forces. So, what does 2,2-dimethylpropane ada is membujur, maksudnya dia punya atom-atom ni duduk jauh daripada satu lain. While N-pentene ni duduk semua dekat-dekat, macam compact dalam bola ni. While this macam kita lebarkan. So, ibarat you nak buat roti, you nak buat kuih raya, you dah bolong-bolong-bolong, you ulikan jadi bola, while lagi satu ni, you lenyekkan dia jadi panjang. So, the more panjang this, the more straight change, we have greater contact area. Maksudnya, lagi banyak area yang terdedah untuk kita polarize. Lagi banyak area yang untuk ada partial positive charge and partial negative charge. While this, some of those charges are very close together, they tend not to have partial positive or partial negative. They don't tend to be as it is. So, take note that usually kalau straight chain molecule, so straight chain molecule have stronger London forces, than branch molecule. Lah saya tulis kat lain lah, tak muat lah. Saya tulis sini lah. So straight chain has stronger London forces than branch molecule. Apa maksud straight chain and molecule? Okay, kalau you tengok, because nanti bila you belajar organic chemistry, you akan belajar juga benda ni. This is also an isomers. So, kalau you tengok, carbon ni disusun carbon ke carbon ke carbon ke carbon ke carbon dalam straight chain. So, dia orang ibarat tali yang disusun antara satu sama lain, ataupun rantai motosikal awak tu. Macam satu rantai ke satu rantai ke satu rantai. That's why we call it straight chain. While branch, dia macam pokok, nampak tak? Batang pokok, dia ada satu branch, dia ada dua branch, dia ada tiga branch, empat branch. These carbon are connected to 1, 2, 3, 4 carbon at the same time. They connected to 4 carbon, while this carbon only connected to 1, this carbon only connected to 2, this carbon only connected to 2, same as this, and this is only 1. So what it is straight chain, has greater contact area, dan stronger London forces. Okay, boleh?
Boleh.
Ada apa tak faham tak? So far. Terus nanti ada quiz. Ada quiz. Okay. Kalau everything okay, I'll go to the third forces. Kita belajar 3 je. Van der Waals ada dipole and London forces. And then kita dah habis dah Van der Waals forces ni, kita akan tengok hydrogen bonding. Okay, hydrogen bonding is my favorite intermolecular forces because it's easy untuk korang ingat. Dia only lah between hydrogen atom dengan only these 3 atom yang bersambung dengan hydrogen. Itu je. Cara nak ingat is hydrogen bond only ada dengan molekul yang ada one of these 3. F-O-N. Okay, ingat phone. Okay. This bond only between H and phone only. Cara nak ingat hydrogen bond, ingat phone korang. Hydrogen bond is only between hydrogen. Well, the name say hydrogen, of course they involve hydrogen kan. Takkan nama hydrogen they involve carbon only. So, hydrogen bonding is only between hydrogen and phone. Fluorine, oxygen, nitrogen. Only 3 atom ni je yang boleh buat hydrogen bonding. So, what actually hydrogen bonding is? It's a dipole-dipole interaction acts between a hydrogen atom as covalently bonded to a highly electronegative atom. So, highly electronegative atom. So, kita orang dah, so the scientists have classified that the highly electronegative atom is only these 3 atoms: fluorine, oxygen, and nitrogen. And we know fluorine is the most electronegative atom kan? Most electronegative atom. So, hydrogen bond is only between hydrogen tapi and with FON only given if kalau the FO atau N is bonded to another hydrogen. Kalau dia bonded to carbon tapi tak ada hydrogen, it cannot do hydrogen bonding. So what happen is kita attraction between hydrogen and FO atau N. It's very simple. Right? Hydrogen bonding is only attraction between hydrogen and FO atau N. So, let's see example untuk clarify on apa sebenarnya yang tertarik itu. So, NH3 liquid. Okay, dia ada hydrogen, so it can make hydrogen bond, and it's also a covalently bonded to N, which is one of the F, O, and N. So, it can make hydrogen bonding. So, for an example, 2 ammonia punya liquid. So, NH3 and NH3. So, bila kita buat dia punya molecular geometry, dia akan bentuk macam ni lah. Trigonal pyramidal. So, apa yang tertarik tu, kenapa dia boleh tertarik dengan F, O, and N? Sebab these element have lone pairs. So, apa yang tertarik tu, hydrogen ni tertarik dengan lone pairs of the nitrogen. That's why it can make hydrogen bonding. Okay, let's see pula air. Air is the most important thing in our life. The reason why kenapa scientists theorize that life can exist in Earth, kenapa instead of just molecule, kenapa kita from the start kita dah ada microorganism yang akan evolve into more complex life? Because of hydrogen are able to create hydrogen bonding. So air bila dia boleh buat hydrogen bonding ni, that's why nanti kita tengok kenapa air, kalau yang awak bekukan, ais akan terapung dalam air. Okay, walaupun dia on the same molecule. So kalau you tengok untuk air, it's between the hydrogen and the lone pair of the oxygen. So cara kita nak check, it has hydrogen. Okay, good. Hydrogen tu is covalently bonded to F ataupun O ataupun N. So good. So it can make hydrogen bond with itself. So molekul air yang pertama boleh buat dengan molekul air yang kedua, sebab molekul air kedua pun ada hydrogen. Ada juga they covalently bonded with F ataupun O ataupun N. So it can make hydrogen bonding. So this is what hydrogen bonding is. Okay, now let's see the example of apa yang walaupun nampak macam boleh hydrogen bonding, tapi dia tak boleh buat hydrogen bonding. Okay, consider ethanol. Okay, ethanol boleh buat hydrogen bonding tak? Boleh tak? Dia ada hydrogen, and then hydrogen ni bonded to F ataupun O atau N tak? Kan?
Ada.
Yes, so ada. Good. It means dia boleh buat hydrogen bonding. So the hydrogen akan bond dengan the lone pair of the oxygen, making hydrogen bonding. Tapi macam mana pula kalau the same thing, ethanol, tapi sekarang dia duduk dengan methane. Okay, jom kita tengok. So tadi kita tahu ethanol boleh buat hydrogen bonding kan, sebab dia ada hydrogen, dia covalently bonded with F ataupun O ataupun N. So dia boleh. So you rasa this lone pair boleh buat hydrogen bonding dengan ni ke? Jom kita tengok. Okay, first dia ada hydrogen, so maybe dia boleh buat hydrogen bonding. Tapi each of these bond dia dengan carbon. So carbon is not F ataupun O ataupun N. So kita tak boleh buat hydrogen bonding. So hydrogen bonding kita tak boleh buat sebab hydrogen dekat sini dia tak covalently bonded to F ataupun O ataupun N. Dia tak bonded to punya korang punya fold. So kita tak dapat hydrogen bonding. That's not a hydrogen bonding. Sebenarnya tak ada pun bond. Okay. So everyone is boleh faham pasal hydrogen bonding? Okay ke?
Boleh.
Okay. Remember, it's only between hydrogen and phone only. Okay, remember you punya phone, fluorine, oxygen, nitrogen. Okay, and it has to covalently bonded. Okay, hydrogen is not bonded to F ataupun O ataupun N. Okay, this is to reiterate the strength of intermolecular forces. Okay, the weakest one is the London forces, sebab it's only temporary. Untuk setengah masa je dia akan ada the partial positive and partial negative. That's why it's the weakest. Paling senang lah you nak break the forces. While dipole is permanent. And all the time it will have positive and negative charge. So dia susah lah sikit sebab setiap masa dia ada positive and negative charge ni. London forces ni setengah masa dia tak ada pun charge. So that's why it's the weakest. And dipole forces is the strongest. It's stronger than London forces. Sorry. Hydrogen bonding is the strongest sebab we have FON ni. FON ni kita usually akan bonded with diorang punya lone pairs ataupun diorang punya elektron lah. and it bonded with hydrogen. So as you guys know, hydrogen is positive and apa charge tiga ni? Chlorine, oxygen, nitrogen. Tahu tak? Okay. Most of the time they have a very strong negative charge. Okay. Chlorine, it is the most electronegative element. Dia paling suka nak ambil. So that's why most of the time they have this very strong negative charge, and hydrogen is very pemurah lah. Suka sangat nak bagi. So that's why hydrogen bonding is the strongest, paling kuat. Okay, remember hydrogen bonding is the strongest, dipole-dipole is in the middle, while London is the weakest. Okay, now kenapa korang bekukan air, okay, letak dalam peti ais, okay, letak dalam peti ais, and then bila air tu jadi ais, dimasukkan balik dalam air, kenapa ais tu terapung? Even though they are the same molecule, both ice and water are both H2O. By korang letak dalam peti ais, kurang ke H2O? Tak kan? You still have the same molar mass. Molar mass of air and ice are the same. Tapi korang letak dalam air, dia terapung. Dia lagi ringan. Kenapa? Okay. Remember tadi pasal, saya tunjuk mana meter saya. Okay. Pasal oksigen, kalau you buat air, you buat dia punya molecular geometry, you akan dapat V shape. So it has two lone pairs. So these two lone pairs are able to create hydrogen bonding to two other water molecule. So each of the one water molecule boleh buat with two other water molecule. So what will happen is, bila you sejukkan, you kurangkan tenaga dalam dia punya sistem ni, they tend to create more hydrogen bonding. So bila dia create hydrogen bonding ni, the effect of one molecule can create with two other molecules. Okay, dia orang akan susun dalam bentuk tetrahedral. Kita nampak tak tetrahedral? Dia macam ni kan? Macam ni. Bentuk tetrahedral. So bayangkan, each of these are water molecule, this is water molecule, this is water molecule, this is water molecule. So what happen is, bila dia orang ada hydrogen bonding, the water molecule will spread further away. That's why kalau orang cakap jangan letak botol air, kalau nak buat ais, jangan isi sampai penuh. Betul tak? Sebab kalau awak letak isi sampai penuh, you letak dalam peti ais, buat ais, nanti botol air tu pecah. Pernah tak tengok? Okay. The reason why is, water molecule H2O ni, bila sejuk, dia buat hydrogen bonding, dia duduk further away. So it create more empty spaces. That's why ice actually expand. Thus, the density is lower than water. Okay, this is a structure of ice. Kalau you tengok, ice form tetrahedral arrangement. Thus, kita have more empty spaces. And these empty spaces ni, dalam ni, sebelum ni air tak ada. Air, dia orang tend to duduk very close together. Dia orang maybe ada satu hydrogen bonding. Dia orang tak buat dua-dua. Once dia sejukkan, dia orang akan create two hydrogen bonding, thus making a tetrahedral punya ice crystals. That's why ice kembang bila dia disejukkan. So that's it untuk today's punya lesson. Any question? Ada soalan tak?
Tak ada.
Tak ada means you guys would be able to answer this quizzes lah. Boleh? Okay, so quizzes. So look at this. Sekejap. I give here. Can someone give to siapa yang tak ada laptop or on the phone, hantar dalam question tu. This quizzes. Kita akan start pasal intermolecular forces. So very short quiz lah. Ini soalan dah masuk. Mostly tanya pasal van der Waals forces. Does anyone have trouble nak masuk? Can someone tolong I letak dekat dalam group. So siapa yang tak boleh tak input, I dah letak dalam group. Don't worry, it's only 4 question. Tak susah pun. Baru 5 orang, mana yang lain ni, ha? Siapa TS cincau tu? Awak dah harga
Lapar tu.
Apa? Mahal tak TS cincau dekat tempat awak? Sekat tempat saya, kat sini dah RM3. Mahal. I think it's cheaper kalau you guys beli kat kedai buat air biasa instead of TS cincau tepi jalan tu. So 14 participants, the other 4 people. Mana lagi 4 orang. If kalau tak boleh masuk tak apa, just let me know tak boleh masuk and I'll just start the task lah. Later I'll give the link to the class. You can try it. So everyone okay? Dah. Lah saya start je lah. Okay.
Okay.
So I'll start the quiz. So, ingat van der Waals forces hanya ada 2. Dia boleh pilih 2. There's only 2 forces van der Waals. Kita belajar 3 je forces ni. Dua van der Waals and 1 hydrogen bonding. Okay, one last before. Okay, good. So yeah, it's London, okay, forces and dipole forces, okay. It's between the permanent charge, the permanent partially positive or negative, and also London, which is temporary, okay. Now let's go to the second question. So dipole forces. Okay, so we have van der Waals, kita have dipole and London kan. So dipole is polar, and non-polar is London, okay. And hydrogen is the special one between hydrogen and your food. Okay, let's go to the third question. Don't worry, ada 4 je question. Tak banyak pun. Yes, very good. So London is only for temporary. At any time dia boleh ada positive or negative charge. Also at any time dia boleh tak ada langsung charge. Sebab it come from probability of the electron. Okay. And the final question, very simple. Dipole forces are stronger on ni tak dipole from permanent permanent dipole moment kan. Okay, so that one is a lot, like half of the class got it wrong. For this one is dipole forces. So ingat tak, dipole forces come from permanent charge. So lagi polar, lagi kuat lah forces dia kan. So polarity kita tengok from electronegative punya atoms. So kalau molekul tu ada elektron yang electronegative dia very high, contohnya fluorine, it will be strong. It will have stronger dipole forces. Okay. So who's the first place? Pika. Good job, Shafika. Ulama, a lot of people got 100% right. It's very good, very good. Pika, Atikah, Nurul, siapa para boy ni, ha? And Ayuni. What is it? Okay. Good job. I think you guys boleh start continue on 7.3. 7.3 kita dah habis. Next week kita akan discuss on tutorial. Okay. So what I want you guys to do, buat tutorial 7.1, 7.2 and 7.3, and I'll pick the question yang susah saja. And also next week, any question yang you guys tak boleh buat, tanya. So we can discuss together in class. Kalau awak tak tanya, saya assume you guys boleh buat lah. And saya akan discuss question yang saya think that it is hard je. Boleh?
Boleh.
So, any more question? Tak ada? Korang tak tahu pun apa yang korang tak faham?
Tak faham apa yang boleh. Ya.
Okay, tak apa. Buat dulu question tu, buat tutorial 7.1, 7.2 and 7.3, and next week kita akan discuss. Okay? So, thank you for coming to my class.
Okay.